Here we have a pair of equations. If we should plot these equations on a graph, the point of intersection of both equations would be the solution of the equation itself. So here we have a straight line, and this is like an ellipse. So where the line cuts the ellipse would be where the points of intersection would be the solution of the graph. So at the end of the video, we'll examine the graph of both equations and look at the point of intersection as well. Let's label this as equation A, and this one is B. And what we're going to do is to solve it first, and then we can look at the graph. Let's make x the subject of the formula from equation A. So it means that x equals to 3 minus 2y. And let's label this equation as equation A1 since it is formed from A. And what we are going to do is to substitute this value in equation B. Therefore, from equation B, we would have x squared, and x is 3 minus 2y. That square means that you times it by itself, so 3 minus 2y again, times by itself there. Minus 2y plus 4y squared. Let's minus 18 both sides, so we would have minus 18 here, and that equals 0. Let us simplify and solve this. So that would be 9 minus 2y times 3 would be minus 6y. Minus 2y times 3 there again, that's minus 6y. When we add them together, we get minus 12y. Minus 2y times minus 2y, that's positive 4y squared. Minus 2y plus 4y squared minus 18 equals 0. Let us simplify and solve. So that would be 4y squared plus 4y, that's 8y squared. Minus 12y and minus 2y, that's minus 14y. 9 minus 18, that's minus 9. And that equals to 0. So here we have a quadratic equation where the coefficient of y squared is greater than 1. So I've done several videos in my video description on how to factorize quadratics of this form. So I won't explain the factorization. We'll just go through and write down our values. So here we would have 4y, and I would have 2y here, minus 9, and this would be positive 1. So now we can solve for y. So 4y minus 9 equals 0, or 2y plus 1 equals 0. So from this we can see that y is 9 over 4. And here y equals minus a half. So now we can find the values of x. When y, because there are two values of y, we need to substitute them back into equation A1 to get x. So when y equals 9 over 4, from equation A1 we have x as 3 minus 2y, and y there is 9 over 4. So that would be 9 over 2. So what we get there is there. So 9 from 6 is minus 3 over 2. So we get minus 3 over 2 for that one, which is minus 1.5. So the solution then, the x value would be minus 1.5, and the y value is 9 over 4 as an ordered pair. Now let's work out the value when y equals to minus a half. So from equation A1, when y equals minus a half, it means that x equals to 3 minus 2 times minus a half. So what we get here then is this 2 would cancel out that, so that becomes minus 1 there. So minus 1, that's going to be plus. So 3 plus 1, that's 4. So our next value is, next coordinate is 4 and minus a half. Let us plot the graphs now. So our first equation is x plus 2y equals 3. So that's the equation of our first graph. Then we have our second graph as x squared minus 2y plus 4y squared equals 18. So the point of intersection we said was the solution for the equation. So here the first solution there is minus 1.5 and 2.5, which is consistent with our value in our calculation. And the next point of intersection here is 4 and minus 0.5. Also consistent with our solution. So let's make this a little bit bigger. So here the point of intersection here is minus 1.5 and 2.25. So this is minus 1.5 and 9 over 4. And then this one is positive 4 and minus a half, which is consistent with our calculation. Thank you very much.